Good morning, guys. How you doing? So today we'll talk about cosine, secant, and cotangent functions and cosecant functions. So basically reciprocals of trigonometric functions. This is the example from yesterday's class, and I did that in the class video which was posted. So just a reminder that from the unit circle was something like this. Radius 1 unit. From this unit circle, the sine of theta was y, because sine was the y coordinate, which was y, divided by the radius, which was 1, so just basically y. The cosine of theta was x, divided by 1, which is still x, and the tangent of theta was y divided by x. So a reminder again, because we talked about these reciprocal functions in the beginning, the reciprocal of sine, so basically 1 out of sine theta, is mathematically called the cosecant function. It's 1 out of sine theta, so therefore it's 1 out of y, because sine theta is y. The secant of theta, again, mathematical name for the reciprocal of cosine. If I have 1 divided by cosine theta, instead of writing this whole thing, I'll just write secant of theta, and therefore it is 1 out of x. And cot, or cotangent, abbreviated as cot, is the reciprocal of tan of theta. And if tan theta is y over x, then the reciprocal of tan theta will just be x over y. We can also find values of these reciprocal functions together with the normal trig functions. If I have this angle for pi out of 3, remember pi is 180, 180 divided by 3, 60, 60 times 4 is 240, and I want to find the ratios of 240. Remember, on this circle, the unit circle, 240 is in this quadrant over here, 240 degrees. This is 180 degrees, so the reference angle for 240 is 60 degrees. Now I know that 240 is going to have the same ratios as 60 degrees, except for the fact that some of those ratios will be positive and some of those ratios will be negative. So using all students take coffee, ASTC, all are positive. Sine is positive in the second quadrant, tan is positive in the third quadrant, cosine is positive in the fourth, the rest are negative. So therefore the sine of 240 will be the same as the sine of 60. The only difference will be that it will be negative. I hope you remember from that equilateral triangle of sides 2 units, 2 units, 2 units, 2 units, that the sine of 60, this was square root 3, that's 1 and 1, that the sine of 60 degrees was square root 3 divided by 2. And since that's the sine of 60 degrees, that means that the cosecant of theta, let me just take this triangle out because I need to use this area. The cosecant of theta is 1 out of sine theta, so the reciprocal of sine theta, and since sine theta is root 3 out of 2, its reciprocal is 2 divided by root 3. But remember, I want to write this without a radical in the denominator, so multiply both the numerator and the denominator by root 3, and then I end up getting 2 root 3 divided by 3. The cosine of theta is the same as, the cosine of 240 is the same as the cosine of 60, and from that equilateral triangle which was in this area and it disappeared, the cosine of 60 is a half, so therefore the secant of 60 will be 1 over the cosine of 60, which will be 2 over 1. Just forgotten to add the negatives. Sine is negative because it's in the third quadrant. Cosine is also negative because it's in the third quadrant. The tan of theta, again from that equilateral triangle, the tan of theta was root 3 divided by 1, and therefore the cotangent of theta, or the cot of theta, is 1 over tan theta, which is the same as the reciprocal of this, reciprocal of that, which will be 1 over root 3, and it is positive because in that quadrant tan is positive. If the cosine is negative, that means the secant is also negative. If the sine is negative, that means the cosecant is also negative. The cosec is also negative. So yeah, that's how you do that. Just a reminder, in this quadrant, all are positive. In the first quadrant, all are positive. In the second quadrant, only sine is positive, only tan is positive, only cosine is positive. The abbreviation is all students take coffee. So all students take coffee. If sine is positive, cosecant is positive. Tan is positive, cotangent is also positive, and if cosine is positive, secant is also positive. Sine positive, cosecant is positive. We can use this knowledge to find all of the trigonometric ratios of an angle. Now, we've been given in this example some restrictions. We've been told that sine of theta is 5 out of 13, and we've also been told that cosine of theta is less than 0, which means it's negative. Sine of theta is negative 5 out of 13, cosine is negative. The only quadrant that meets those two preconditions is the third quadrant. It's not this quadrant because here all are positive. It's not this quadrant because here sine is positive. It's not that quadrant because in there cosine has to be positive. And it says here that cosine is negative because it's less than 0. So that angle is in this quadrant. And I can draw a triangle, let me use red. I can draw a triangle in that quadrant. Right angle triangle to represent that angle. So that's my angle theta, right angle triangle. Since sine from SOHCAHTOA, sine is opposite divided by hypotenuse, right? And this is given as negative 5 out of 13 or negative 5 over 13. That means the opposite is 5 and the hypotenuse is 13. So I'm going to name my opposite here as 5 and my hypotenuse as 13. Now this negative, I think you can see clearly here that on the y-axis I'm going below the y-axis. That means the 5 is negative because I'm going below the y-axis. This is a right angle triangle. I don't know what the x value is, but I know the y value is 5, and I know the x value, the hypotenuse is 13. So I can use Pythagoras. X squared plus 5 squared is equal to 13 squared. I can use Pythagoras to find the value of x. And if you do the math, you'll find that x is 12. So I know the value of x, it is 12, and it is negative because as you can see, I'm going on the left side of the x-axis. So x is negative 12, y is negative 5, hypotenuse is 13. So if I want to find the other ratios, first of all, I've been told that sine is negative 5 divided by 13. Therefore, that means the reciprocal of sine, which is called cosecant, CSC, this is S, no, CSC of theta is the reciprocal of sine, which will be negative 13 divided by 5. I can get cosine of theta from this triangle. Cosine will be adjacent divided by hypotenuse, according to SOHCAHTOA. Adjacent is negative 12 divided by 13, and its reciprocal, also known as sec of theta, will be negative 13 divided by 12. I can find the tangent of the angle because I was asked to find all the remaining ratios, all the remaining functions. The tan will be opposite over adjacent, which is negative 5 over 13, and therefore the cot will be the reciprocal of the tan, which will be, oh sorry, this was positive. No, it's negative 5 divided by negative 12. Sorry again. Negative 5 divided by negative 12, opposite over adjacent. So this is 12. Negative 12. Okay. Negative 12. And both of them cancel out to give you a positive, which is what I expect for tan to be positive in that quadrant. So it still checks out. And this is the reciprocal of tan is cot, which will be 12 out of 5 positive. So that's how I can find all the other ratios after having been given some preconditions. I hope you remember even an odd functions from polynomial functions last semester, and we said that if the input value is, if the sign of the input value is changed to become the opposite sign, and that doesn't change the output value, then that function is even. But if the sign of the input is switched and that changes the output value to become negative, then that function is odd. You can practice on your own. Try finding the cosine of 60. We know that that is a half. And then also try finding the cosine of negative 60. On your calculator, you'll see that you still get a half. So even when I change the sign of the input value of this function, it doesn't change the output value. It stays the same. So that function is even. Try the same thing on sine. You'll find that sine of 30 is a half, but the sine of negative 30 is negative 1/2. So that means that the function is odd, because switching the sign of the input value leads to a switch or change in the sign of the output value. So since secant is the reciprocal of cos, then it also will be an even function. And since cosecant is the reciprocal sign, it will be an odd function. Since tan involves a sine function which is odd, then the tan function will also be an odd function, same as the cotangent, because it's a reciprocal of tangent. Proving trigonometric identities. Trigonometric identities are things that you are like trig relations, formulas that happen to be true for trigonometric functions. Let me show you what I mean. If you look at this unit circle, I have a triangle, a little triangle with legs x, y, and hypotenuse 1. If I apply Pythagoras theorem to that triangle, I'm going to see that x squared plus y squared is equal to 1, right? But also taking you back a little bit, I hope you remember that in this same triangle, we saw or discovered that the sine of the angle is y and that the cosine of the angle is x. So since the sine is y and the cosine is x, and Pythagoras tells me that x squared plus y squared is equal to 1, I can substitute for x and y as cosine and sine. So in place of x in this formula, because this formula is x squared plus y squared is equal to 1 squared, which is just 1. This is 1 squared, that is just 1. X squared plus y squared is equal to 1. Therefore, if I substitute for x as cosine, I will have cosine of theta squared plus sine of theta squared is equal to 1 squared, which is just 1. Now this is the first trigonometric identity. And to avoid having to write parentheses all the time, in mathematics, we can simplify or rewrite cos squared to just be cos squared theta. If I put the square on top of the cosine function, in between the function and the angle, that means that the whole function is squared. It is not the same thing as cosine of theta squared, so be careful. This means that the angle is squared, but this means that the function is squared. Okay, so don't confuse them. If I write the square on top of the function or in between the function and the angle, that means the whole function is squared. This kind of writing or notation is just to help us avoid having to write the parentheses every time. Plus sine squared theta is equal to 1. This is the first trigonometric identity, and this trigonometric identity can give birth to 2 other identities. So there's 3 identities that we're going to talk about. This is the first one. The second and third sometimes are written in different order depending on what you do first. Let me show you. So the first one is cos squared theta plus sine squared theta is equal to 1. If I like tinkering and I decide to divide this expression, every term of this expression, if I decide to divide each term of the expression by cos squared theta, then I get something interesting. First of all, this being cosine and cosine, it cancels out, right? So it cancels out and I'm left with 1 because I'm dividing cosine divided by cosine, so I'm left with 1. On here I have sine squared, which is basically sine theta cross bracket squared, divided by cos squared, which is cos theta cross bracket squared, and since they're both squared, I can write them like this. equals, and this can be written as 1 divided by cos theta squared, because 1 squared is still 1. Now, I know that sine theta divided by cosine theta is the same as tan of theta, because if you remember, tan of theta from our unit circle was y out of x, and yet y was sine and x was cosine. So tan of theta divided by, sine of theta divided by cosine of theta is tan. So I can write this as 1 plus tan of theta squared, right? Remember, you can put it out there, or to make life simpler for you, you can just put it there. It's the same thing if you put it correctly. If you put it here, not the same thing. Is equal to 1 out of cosine. I hope you can see this is the reciprocal of the cosine, and there's a special name for that. It's called the secant theta, which is the same as sec squared theta. Okay, this is the second identity, or like I said, depending on what you divided with first, it could be the third identity for you, but this is the other identity, one of the three. The third one, again starting from cos squared theta plus sine squared theta is equal to 1, starting from here. And again, I like to tinker. This time I divided by cosine. This time I can decide to divide by sine. If I divide each of these terms by sine squared theta, then what we see, something interesting, is that gives me 1, right? This on the right over here, 1 divided by sine squared is basically 1 divided by sine, and the reciprocal of sine is called cosec or cosecant. This is what I'm talking about, 1 divided by sine squared. And over here I have cos theta divided by sine theta squared. So let me start with this on the right. 1 divided by sine is the same as cosecant. That's easy. That's an easy one, cosecant theta squared. Then I have my 1 and then plus. So take this down here for a little bit. I know that tan of theta is equal to sine of theta divided by cosine of theta. But if someone writes cosine of theta on top divided by sine of theta, they've basically written the reciprocal of tan, because this was sine over cos and this is cos over sine, is the reciprocal of tan, and we know the reciprocal of tan is an identity called cot theta. So basically what I have here is cotangent of theta squared. This is the third identity. So the first identity was cos squared plus sine squared is equal to 1. The second identity is 1 plus tan squared is equal to secant. And the third identity is cot squared plus 1 is equal to cosec squared. It's going to be quite challenging for you to try to memorize them in the beginning, but with time, and as you use them more and more often, you'll see that they are quite easy to memorize. As long as you have this one down, because this is the one that produces these other two, you can just decide to divide by either sine or cosine to get to the other ones. These identities are going to be very useful in simplifying proofs or proving certain relations in trigonometry. Now, in this course and also in calculus in the future. Example, if I want to evaluate the following using a graphing calculator, just plug this into your calculator and get the answer. This one is cotangent of pi out of 18. Pi is 180. 180 divided by 18 is 10. So basically the cot of 10 degrees, which it's asking you for 1 divided by the tan of 10 degrees. Give your answer to 4 decimal places. Tan of 1, that gives you something. Cosecant of 55 is asking you for 1 divided by the sine of 55. Give your answer to 4 decimal places. The other one you might want to check out is tan of 45. Interesting result as well. Okay, so I hope that was helpful. I know you finished this already, so go ahead and do the rest of the homework.